says you buy a used truck for this amount of money, $22,000. It depreciates at the rate of 10% per year. What is the value of the truck after 4 years? What does the word depreciate mean? It goes down, right? So I would use the model that we've talked about, y equals 1 minus the rate raised to the power of the time, right? So let's go ahead and write this out. What is my rate?
Your rate is the money. It's 10%.
Rate is 10%. What'd you say, Graydon? Yeah, x is going to be the time up here. You can put an x or a t. Okay? What is the starting amount that we have? 22,000 times 1 minus, and then I've got to change this percentage to a decimal. 0.1. I'll zoom in so that y'all can see. 1 minus 0.1 raised to how many? Raised to the power of 4. So if I simplify this, I'm going to get 22,000 to the 0.9 raised to the 4th power. What kind of function is that? What have we been working on?
Exponential.
It is an exponential. You have to be able to recognize that that is an exponential when it's written like this. Anytime a number is being multiplied and then raised to a power, it's an exponential. As long as this... all right, that's a good question. You see how this is raised to the power of x? Anytime that there is a variable as an exponent, that is an exponential, okay? Number two says graph this function. Anytime that you see the word graph and then it gives you a function, create a table and then put it in your calculator. Create a set of values, x's, and then you will find the y's when you put it in your calculator. So I'm going to just do the standard -2, -1, 0, 1, and 2. So I'll go here, and then it is 2. It is 2 raised to the x power. So the caret is the raise, and I'm going to hit enter. I will get the graph, but I cannot sketch a graph yet. I need the table. So menu, table, split screen. So let's go up to -2. The value of x is, or the value of y when x is -2 is what? 0.25. So I'm going to put 0.25. What is the y when x is -1? 0.5. What is the value of y when x is 0? 1. The value of y when x is 1 is 2. The value of y when x is 2 is 4. Even if you don't know how to graph, you now have a table of values. Plot these values. -2, just above. -1, halfway. 0, up 1. 1, up 2. 2, up 4. If we continued it, it would be 3, up to 9. Now I can sort of sketch this graph. I know it doesn't ask for it, but it's a good teaching point. What is the domain of this? Okay, yeah, but what is my x? Well, now we're looking at the graph now, Graydon. If they'd only gave you a table, yes, you're correct. I have a line. So are there any breaks in that line? I've got arrows, right? Okay, so my domain is how far left to how far right. It continues on forever here, continues on forever here. Yep, it's going to be the little infinity sign. The reason that there's no line underneath is because infinity is sort of a, I guess you would, I'm trying to think of how you would. Sideways 8. If it touches it, there's a line underneath. If it never touches it, there's no line. Okay? You'll never get to infinity. It's sort of like not a thought, but I guess you would say, yeah, it's kind of a concept. Now, what about my range? Does it ever go below the x-axis? Does it ever touch the x-axis? So what is the y value at the x-axis? 0. So it's y is greater than 0. And we will have it, it's going to be on the classroom, so know that it'll be there. I'm going to flip. Alright. Says create a table for 2 times 5 to the x power. Doesn't matter what your x's are. I'm just putting -2, -1, 0, and 1. No. I'm going to go back to my calculator. Go back to the calculator. And I'm going to start over. New document. No. Add a graph. 2 to the 5th. Or 2 times 5 to the x power. What's the only thing that this problem is asking you for? What the y values are. So create your x values like we have, and then add a table. And so it's going to be 0.08. 0.4. This will be what? It'll be 2. If there's a number in front, Greg, you see how there's a number in front? If there's no number in front, it will be 1. If there's a number in front, it will be that number. I'll show you why here in a second. And then it'll be 10. Here's why it's like that, Graydon. Because I have 2 times 5 to the x power, right? So if I stick 0 in for x, this would be 2 times 5 to the 0th power, correct?
Yeah.
What is 5 to the 0th power? It's going to be 1. So I'd end up with 2 times 1, which is 2. But this is not times 0, this is raised to the 0th. Alright? Number 4, it's another one of those what kind of functions. says you deposit $500 in an account that pays 5% interest yearly. How much money is in the account after 4 years? So if it's getting interest, are you gaining or losing?
You're gaining.
Gaining. How much do I start with?
500.
Is it going to be 500 plus 0.05 times x, which would be 0.05 times the number of years? Does that make sense?
No.
Because then I'm only getting like 20 cents. So I'm going to do 500 times 1. You said I'm gaining money, so it's plus. What's 5% as a decimal?
0.05.
0.05 to the x power, because x is a number of years. So this reduces to 500 times 1.05, because I can put those together, raised to how many years?
4.
And what kind of function is that?
Exponential.
It's another exponential. Number 5, it wants to know whether it's growth or decay. What's going to be growth? What has to happen with growth? Okay, here's my function. Y equals AB to the x, right? What do we know about growth in this b value? It has to be what? And what makes something grow when I multiply? The b must be larger than 1. What about decay? What do you think the b is going to be? B must be between 0 and 1. So I'm only looking at that value right there. Is that number bigger or smaller than 1? If I reduce it, it's 8 divided by 7, right? And if I put that in a calculator, it will be larger. So which one is this? Is it growth or decay? It is growth. What's the question? 1. I'm sorry. There you go, girl. All you got to say is, hey, Coach, I can't see it. I'll scoot it over for you. You got it copied down, Emily? All right. Number 6 says biologists have observed a bacteria culture for a few hours, and using calculators to perform an exponential regression, they came up with the exponential function, and it gives us the exponential function right here. What is the rate that the bacteria were growing? Okay. We haven't really looked at something like this, but remember, it's a times b to the x, and b is either going to be 1 plus or 1 minus our rate, correct? Is this number, 1.5, is it bigger or smaller than 1? It's bigger. So I'm going to say that it's 1 plus the rate. So all I need to do is to solve for r. Subtract 1 and subtract 1. So what is left over? 0.5. So what is 0.5 as a rate? If I wanted to change that to a percent, what would I do? I would do 0.5 times 100, which would give me 50%. That is a 5. Don't try and get it all down. Remember, you can watch it as many times as you want. What? What is the range? What is range? Range is y. This is the y-axis, isn't it? So box it in. It's from here up to here. What kind of circles do I have? Points. What do closed mean? Okay, with inequalities, is it like this or like this? Which one is it? It's these. Because closed in circles means that it can equal. Open circles cannot equal. So I'm looking for my smallest y value. What's my smallest y value? So I'm going to start here, and I'm going to go up. 1, 2. And what do I get? Positive 2 is my smallest y value. So that is smaller or equal to y's, which is smaller or equal to my biggest y. What is my biggest y? 7. So my range is going to be 2 is less than or equal to y, which is less than or equal to 7. Remember, range is y's. That's what you need to know. What is the range for the following? These are arrows. That's an arrow right there, and it is above. It is above right here, okay? This is an arrow. It means it goes on forever. So what does it have to stay above? What does the y have to stay above? Because remember, range is y. Does it ever stop going up? No. So it'll be y is greater than 3. Because the y values will always be bigger than 3 but never touch. Right, David? Number 9. Does this function, and here's the rule, indicate exponential growth or decay? Growth, the b has to be what? B is larger than 1. Decay, b is less than 1, but bigger than 0. That's another way to say it. Right. So is this right here, is this number, remember I'm only looking at that number, is it larger than 1? Okay, so it's got to be growth. It's got to be growth. We kind of getting it? All right. Yeah. Yeah. We're going to keep working. All right, here's where it starts to get difficult. We're given a table. All right? It is, I have to decide what the function is. I need to see, the first thing that I need to see is how much everything changes. How much does all this change over here? By 1 every time, right? How much does all this change? Let's just do a couple of them and see if they're the same. 3. It's 3, 6, 7, 3 minus 3, 4, 2, 5. And that's 248. I'm going to write all this down, okay? And I should get 3921. Do I get 3,921? No. So I know that it is not, I know it's not linear. So it has to be exponential. Okay? So what I'm going to do is I'm going to go ahead and write the exponential function out, which is the y equals ABX. Remember, the A is the starting amount, right? So what's my starting amount at 0? That dude right there. So y equals 3,425 times a number raised to the x power. Let me show you a little trick. If this is truly exponential, I can take this number and divide it by this number, and I'll get something, okay? Doesn't matter which number. So I'm going to take 4,225. So 4,225 and divide by 3,940, and that's what I get. Now, I can also take 3,940 and divide by 3,673, which is the next lowest one, and I should get the same number. But I don't. So what can I do? All right. If this is the starting point, are these numbers getting bigger or smaller? These are getting larger. I can put this number in here, so I can get rid of anything that says decreases first off. So I know that it's not going up the same every time, so I can get rid of that. Now I just have to check to see if C is true. So what's 7 1/4 written as a decimal?
7.25.
It's a percentage. So it'd be 7.25%, but now I have to divide that by 100. Yes, sir. So if this is true, I would do y is equal to 3,425 times 1.0725 raised to the x. So let's take a look and see what that looks like. 3,425 times 1.0725, close my parentheses, and raise that dude to the x. I don't see it, but that's okay. I'll go to table, split screen. Okay. How come it... Well, it would help to have the right number, wouldn't it? Okay, there's 0, 1 matches up, 2 matches up, and 3 matches up. So C is correct. What's the domain? Open circle. No equal. Good. in its domain, so it goes to the x. So take this straight to the x-axis, and what is that value? 1, 2, 3, 4, -5. Take this down to the x value, and this is 1, 2, 3, 4. With an equal to, yes sir. So my small is -5. I guess you need to see it, don't you? -5 is less than x, which is less than or equal to 4. Make sense? Good deal. Josh, come on, man. All right, it wants us to build the equation given this situation. It says freshman students in math class started with an average of 100. So this is like Josh's grade when he falls asleep.
Yeah, both of them.
Okay? So it's going to start off as 100, and then you're going to sleep a little bit, or like it says here, get busy, and the grades go down a little bit. Okay? At a rate of 3% per week. What is a grade after 6 weeks? So I'm going to start off with 100, right? It is declining, right? At 3%. Yes, sir. Now, is this a plus or a minus because it's decreasing? And then x is going to be the number of weeks. So 100 times 1 minus 0.03, like Graydon said, raised to the x. So the only thing that I need to do is fill in this 6 right there. So I am going to go over here, hit tab, press up, 100, 100 times 0.97 raised to the x power when x is weeks. So what is my grade after 6 weeks of being busy? An 83. So 83%. You all right, Josh? That makes 2 of us. All right. I'm going to zoom out a little bit, and then I'll zoom back in if we need to. It says the graph shows the change in the value of a car over several years. Based on the information, which conclusion appears to be true? Okay, so I am going to create a table to help me decide what this is. All right, so it says the car lost the value, or half its value, every 3 years. I'm going to go here, and this is 12. That's my y value, which would be 12, I guess, thousand. Yes, because it says thousands of dollars. It starts off there after 0 years. After 3 years, it's at 6,000, right? What about at 6 years? At 6 years, it's a little bit more than 4, so I'll say 4.5. Okay? Well, what that would look like is, as a graph, I would take 12,000 right? And then it's going to lose half its value, so it's going to be depreciating by 0.5 raised to the x power. So let's take a look and see if this actually fits using our graph. So the 6,000 fits, but the 3,000 does not. So A is out. The car lost about 1/4 of its value every year. Well, the first year it dropped by half of its value, so that one's out. The car lost less than half of its values between 9 and 10. Okay, the car lost less of its values between 9 and 10 than between 1 and 2. So it's saying that it lost less here than it did here. Is that true? Between 9 and 10, how much did it lose? 9 is here to here. It lost less than $1,000. So we'll say $500. Well, what about between 1 and 2? It lost 6,000, right? So is 500 less than 6,000? Okay. So it did lose that. So we're going to keep that. The car lost more of its value between 9 and 10 than 1 and 2. So this is just the opposite. We just said H was true, so it can't both be true and false. What is domain? It's my x values, right? I have arrows, right? So it goes on forever left. Okay, I have an arrow, right? Does it go on forever right? So what is my domain? It is from negative infinity all the way to positive infinity. Ooh, here's a tough one. Here's a tough one. It wants to know what the y-intercept is. Well, remember that exponentials continue to curve, so you're not going to be able to eyeball this guy. I need to get some points. I'm going to do this point right here because it is 150. And I'm going to do this point right here because it is 2 and 75. Remember that it is a multiplication problem. Y equals AB to the x. So I'm going to take this value and multiply it by this. Okay? What is the opposite of multiplication? So divide your y's. Do 75 divided by 100, or 150. And what do you get? What is 75 divided by 150? 1/2. So y is equal to a times 1/2 x. So it's a number times 1/2 to the x. Now I'm going to plug these in. I'm going to plug 275 in. So this is 75. This is a. This is 1/2. And this is 2. What is 1/2 squared? 1/4 is equal to 70, or 1/4 a is equal to 75. How do I get the a by itself? It's attached through multiplication. So divide by 1/4. It's gone. So what is 75 divided by 1/4? 75 divided by 1 divided by 4. So a is what? So which one of these is it? A. All right. What is not true? Remember, A is my starting point. It's where it crosses the y-axis. Is that y value positive? Is this y value positive right here?
Yes.
It's gone. The function has an asymptote of y equals 0. Remember, asymptote is that imaginary line that it'll never touch. Will it ever touch 0? No. So this could be a possibility. The range of f is y is not less, or y is greater than 0. Y is greater than 0. What is the value of b negative? Why is it not negative? Because this goes down, but what creates exponentials to go down? Nope.
When the b is between 0 and 1.
Thank you. Exponentials decrease when the b's is between 0 and 1. So it's D. We'll skip 17. We have to decide whether 18 is true or false. Is this an example of an exponential function? I have x squared minus 5. It is a quadratic.
So the answer is false. Yeah.
It is false.
It's false.
Remember that your x has to be the exponent.
For it to be an exponential, it has to have,
For it to be an exponential, your x has to be as an exponent. Alright? That's the only thing you're looking for. Okay? 2 more. We're only going to go through 20. The following statement could be modeled as an exponential. James needs a taxi ride. Charge an upfront fee of $7.2 or $7.25 and then 25 cents per mile after that. Someone tell me what that looks like. How much money is it going to cost me? How much am I paying no matter what? So that's my starting amount. Am I adding, subtracting, multiplying, or dividing?